Hi, Year 11. So today we're looking at a question on radioactivity. It's from a 2018 paper, and it wasn't the foundation paper, but this content is very much higher or foundation, so it could come up on both papers. And just so happened that this year it came up on, well, in 2018 it came up on the foundation paper. So I'll go through, read through the question, highlight any key bits, and then we'll make a few notes, and then we'll go about answering our question. Once we've made the notes, it might be a good idea if you pause the video, have a go at writing an answer yourself, and then come back and see how you've done. Okay, so a radioactive rock is placed near to the front of a GM Geiger-Müller tube. So I'm going to highlight that. A radioactive count rate is first made in air. So they've first taken the radioactive count rate just in air. Nothing different about the situation there. The count rate is measured again with each of the three different absorbers between the rock and the GM tube. So if you imagine the rock's here, there's an absorber in the middle, and then the GM tube's over here. It says figure 12, it shows the count rate measured, and then you can see the absorbers here. We've got 3 centimetres of air, a thin sheet of paper, I'll come back to why I'm highlighting these, a 3 millilitre thick sheet of aluminium, and a 2 centimetre thick sheet of lead. And you can see it, the count rate is changing, it's falling each time once, the count rate is falling each time as they put different absorbers in front. It says a scientist has an idea that the rock emits 3 different types of radiation. Okay, so let's highlight that. And it says explain how the data in the table supports the scientist's idea. So let's go through and let's annotate everything we need to do. So here we've got Geiger-Müller tube. Now I've highlighted that because that is the piece of apparatus, and when I say apparatus I just mean the fancy word that we use to represent scientific equipment. So it is the apparatus used to measure radioactivity. And when you're talking about a Geiger-Müller tube in the exam, you are fine to just say GM tube, so you don't need to worry necessarily about saying it Geiger-Müller tube. Now here it says a radioactivity count rate is first made in air. Because they're suggesting that it's first made in air, this is indicating that you could mention background radiation. So I'll just annotate background radiation, and we'll come back to that in a second and we'll write a few notes on there. It says the count rate is measured again with each of the 3 different absorbers. An absorber is something that will block or stop the radiation. And then on the table here you can see I've highlighted 3 different materials. These are the 3 different absorbers. Alpha is absorbed by paper. So there's the link there. Beta is absorbed by aluminium. So again, that's why they've highlighted this. And then 2 centimetre thick sheet of lead, gamma, is absorbed by thick lead. So there are 3 different types of radiation that we've just suggested that we need to mention here. So let's make a few notes on background radiation first of all. So background radiation is radiation that is always present, but it's to a safe dose. So it's not necessarily causing us any harm, it's always there and it's emitted by lots of different things. So I'll just write a few brief notes. I'll say always present, but a safe dose. Now there's 2 kind of categories for background radiation. There's man-made and there's natural, so naturally occurring. The man-made ones are things that we use typically for like medical uses like x-rays. So I'll put e.g. medical x-ray in brackets, whereas the natural things are things like food and drink, or grounds and buildings. So some rocks will just naturally emit radiation. Okay, so grounds and buildings. Now, let's talk about our 3 different types of radiation. So, linking to this question, we've got alpha, Now, we already know that alpha is absorbed by paper. We've already mentioned that here, but I'll just make a quick note. So it's absorbed by paper or skin. And that's because it's weakly penetrating. Now, the bit where people get mixed up is they get penetrating and ionizing kind of muddled. So it's weakly penetrating, but it's highly ionizing. So I'll write that down, but it doesn't really have any impact on this question. It's just for your revision. Alpha is made up of 2 protons and 2 neutrons, so I'll just do a little picture there to represent that. Then we've got beta. Beta is made up of an electron, and it's absorbed by aluminium. Thin aluminium. Okay. Now it's still fairly weakly penetrating, so nowhere near as penetrating as gamma, but slightly more penetrating than alpha. So I'll just put fairly weakly penetrating. And it's moderately ionizing, so kind of in the middle. Okay, and then we've got gamma. Now gamma is a bit different. These two are made up of particles. This one is an EM wave, so an electromagnetic wave. And gamma is absorbed by thick lead. It's highly penetrating, so that's why we need thick lead to absorb it, but weakly ionizing. Okay, so the first kind of key 2 points of these bullet points are the key bits for this question. I've just added this because it's a bit of extra content that you'll be required to know for your exam. Okay, so now we've got our notes, it might be a good time to pause. I'm going to now start writing our model answer. Okay, so I'm going to start by saying that the data does support the scientist's idea, and then I'm going to explain why it supports that. And I'm going to use the numbers from the table in my answer to show that I'm using those numbers and I'm understanding what those numbers are indicating. So I'm going to say here, alpha is absorbed by paper. And then I can just say, when paper is present, the count rate drops from 1,272, just got that number from the table there, to 931. And then I can go on and do beta. So we talked about alpha, and I can say beta is absorbed by aluminium. When aluminium is present, the count rate falls from 931 to 328. So I've talked about beta now. So now I need to go on to gamma. So I can say gamma is absorbed by thick lead. When lead is present, the count rate drops from 328 to 21. Okay, so we've talked about all of our 3 different types of radiation, and we've used the data in the table to support our explanation. But now here we've got this reading. So I'm going to finally add another point just to explain this reading here. So I'm going to say background radiation is always present. Therefore, the count rate will never fall to 0. And I'm just going to follow it up with that 21. 21 is in line with background radiation. Okay, so I've kind of split this up a bit just to get the points across, and I've used the numbers from the table. And remember, let's go back to the question. It says, a scientist has an idea that the rock emits 3 different types of radiation. Explain how the data in this table supports the scientist's idea. So we've explained that the data shows that alpha must be present because when the paper's there, something is being absorbed, that count rate's falling. And when aluminium is there, the count rate is falling again, so that suggests beta is present. And when the lead is there, the count rate falls again, so that suggests gamma is present. And then I've also indicated that I know that the reading is never going to be at 0 because there's always going to be some sort of background radiation. There could be some gamma getting through, but we know that that's kind of in line with where we'd expect background radiation. Okay, thank you for listening, Year 11. There will be another video each day.